Media interest in Dr. Joye's and the team's research work is intense. Crews from ABC News, the NewsHour on PBS, writers from the New York Times and the National Geographic all need her time to explain her important work.
The media attention is not something I expected. I'm a bit of a, people find this surprising, but I'm a little bit of an introvert. I don't consider myself someone who has a media presence. I consider myself a complete nerd who often says things that probably sound silly to most people. But I was just shocked at the number of phone calls I got every day, and I tried to make sure that it didn't interfere with what we were doing out there. But I got to tell you, the next cruise I go on, I'm going to disconnect the phones so that nobody can get me on the ship.
The students and research assistants on this cruise are more than passionate about their work. Working 21-hour days to accomplish their mission means working in all weathers, from scorching sun to drenching downpours and almost all sea conditions. Even in the wee hours of the morning, samples from different research stations in the Gulf must be removed from the rosette, immediately analyzed, and stored for further research back at the Marine Sciences Lab in Athens. Surface water samples taken in an intense slick must be handled with utmost caution. The presence of gas and possible chemical dispersants used by BP pose significant risk to the research team. In addition to the normal lighter rubber research gloves, research assistants use these thick rubber safety gloves for protection from the toxic oil. The surface oil has also gummed up the operation of the air conditioning system on board the ship, which uses seawater for cooling.
That's BP sludge on our strainers.
Strainer for what?
Air conditioning.
With the clogged filter, the ship's air conditioning system is down for several days. A Walton Smith crew member examines a souvenir of sorts from the cruise. But what does the oil and gas plume really look like deep under the surface? A professor from the Pelican cruise, University of Southern Mississippi researcher Dr. Vernon Asper, has brought an underwater still camera with him to answer that very question. The camera rig failed on the first attempt, but on the second try it successfully captured images from underneath a mile of water. Dr. Asper is ecstatic.
I can't believe we can see it.
I can't believe we can see it either.
That is awesome.
This image, taken at 170 meters, shows mostly normal ocean water. There are some organic aggregates known as marine snow. This next image was obtained at 890 meters below the surface. At this depth, we're beginning to see what might be oil aggregates. Importantly, the heads of the beads are pointing up. Researchers think this indicates they are rising. At 1,125 meters in depth, the camera is in a cloud with lots of orange oil aggregates visible. Deeper, at 1,140 meters, a white cloud of particles emerges. Researchers believe these to be gas hydrate crystals, but aren't completely certain. And finally, at 1,300 meters deep, below the cloud of oil, marine snow becomes visible, with their heads pointed down. Researchers believe this means they're sinking to the bottom.
There's no doubt that's oil. That's oil.
What's that for? For that. I got pictures of oil droplets in the fluid.
When we return, the research team is confronted with a vivid example of the devastating effects of this deep water blowout on surface wildlife. And will the Gulf of Mexico ever return to normal?